Okay, so by this point you should have either constructed or purchased some kind of a frame to mount all your stuff to. And up until now we haven't really needed to bother with any orientation concerns. But from this point on we are going to have to be a little bit more careful about how we start arranging stuff. So you'll need to decide which is going to be the front of your quadcopter, and I'm going to make that the front. And we need to arrange the 4 motors so that 2 of them are going to spin clockwise and 2 of them are going to spin counterclockwise. So to make sure that we understand which goes where, if you go to Google and do a search for multi-wheel motor layout, you will find, if you scroll a fair way down the page, you'll find this diagram here, and this is the one that we're going to be using. It's the Quadcopter X configuration, and for Arduino 328P, make sure you get the right one. So you can see there the top left motor needs to spin clockwise, and this is when you're standing above the quadcopter looking down on it. This is how the arrangement will be. So top left and bottom right motors clockwise, top right and bottom left. Did I get that right? Yeah. Top right and bottom left motors are counterclockwise. And if you got the same motors that I got, the cheap and nasty ones, well, cheap and kind of okay-ish ones, make sure that you get 2 counterclockwise and 2 clockwise motors. It's not critical, but it makes life a lot easier because the difference between the motors is that they have the thread on here is wound differently. So as you can see, I'm taking this off by unscrewing it counterclockwise. So this motor here, to put the prop fastener on, I screw it clockwise. But that means the prop will be spinning the other way, because the whole point of this fastener being a certain way is so that when the propeller is spinning, it helps to tighten the fastener instead of making it looser. So when I'm turning this clockwise to tighten it, that means the propeller is going to be spinning counterclockwise, which means that this motor is going to be either number 10 or number 11. So I'm going to put this one over there to be my top right motor, and this one here goes the other way. So you see, if I turn this one clockwise, I end up taking it off. So that's going to be top left, and so on. Okay, so what I'm going to do is zip tie these on here, and then I'm going to cut the black wire to just bring it to the right length. I don't want to have any wire flapping around there because that gave me problems last time. I think I had a fairly raw solder joint around about here, and the motor wires were kind of sticking out like that, and I'd fly around for a few minutes and then it would just drop out of the sky. And when I went over to check it, one of the solder joints on these horrible wires had come off. The only thing I can deduce that might have happened was that the wind was sort of vibrating it, and it just sort of broke the solder joint from fatigue or something. So I really want to have these wires strapped flat down here like that. And I think I mentioned earlier that it's a bit of a stretch really to get these zip ties in here, and you're going to need some quite small zip ties to do it. These ones are about 2 millimeters wide, I think, and they're just long enough to get around the balsa beams that I'm using as well. And you want to make it so that the motor wires are coming in like that, obviously. If you have wires on here that are a bit longer and you can't quite fit the zip tie through the way that you want, you could still mount the motor with the wires going outside like that, but it's just a little bit more fragile. If there's a crash, you're more likely to hit onto those wires. So just take it gently. I found that it can take a bit of persuasion to get these through, and most of the time there'll be one way that the zip tie goes through quite nicely, like that way there is not too bad, but this way is almost impossible. So actually I haven't checked yet, but I'm just hoping that I can get the zip ties through the right way that I want to have the wires coming inside like that. So I'll just put a couple of these on and get back to you in a second. Alright, so they go on there like that, and you want to make sure that the way you've put your zip ties on are equal and opposite, so you wouldn't have both of these black fat parts on the same side. It just keeps the tension equal, so I'm told. And obviously you want to make sure that it's centered properly, so you should have put a mark on the side there so you can see where the little depression was in the middle of your mounting area. And if it's on okay and it's free to move, it should be able to spin like that. Okay, starting to look a bit more like a quadcopter now. Fortunately, with the zip ties only being able to go one way through the bottom of the motor, it turned out to be the right way that I wanted in all cases. So it seems like when they make the counterclockwise motors, the motor wires here are sort of slanted a little bit to one way, and when they make the clockwise ones, they're slanted the other way, but it turns out to be just right for mounting them so that the motor wires come inward at a 45-degree angle like that. So next step is to connect the motor wires with the speed controller wire ends here. I might have to cut one of these back, probably both of them I think, because I want the join to be right there in the middle. And right at the moment we don't know for sure which needs to go to which, but we do know that we can connect one of them permanently now, so I'm going to solder that up and heat shrink it and make it nice and tidy. And then the other two, we need to check once we get the flight controller board on here and get that to spin the motor. We need to check that that's going the right way. If it's not, then we need to switch the other two. So there's a 50-50 chance that we'll need to unsolder or disconnect two of these wires and switch them. So I'm not going to permanently solder those up just yet. Okay, that is what I was talking about. And make sure you check that joint really well, because if you're going to get a cold solder joint anywhere in this project, that's where it's going to be. And like I say, this black wire here is single core wire and it doesn't like being moved. And this little point where the solder joint's on, if it's moving around like that while you're flying, it's probably going to just break through right there. So that's why I wanted to have it so that I could really just, like, I might just tape it down like that once it's heat shrinked. Remember to put your heat shrink on as well. That's annoying, isn't it, when you forget to do that? Yeah, so it's going to be taped on there so it can't move at all at that join. That's my recommendation from my experience. Okay, I'm just coming to the end of all the motor connections here, and I thought I'd give a few tips about it for somebody who may be doing the same kind of arrangement that I'm doing, because it was pretty tricky and it took me a few tries to work out a good way to do it, mainly because joining wires to end like this is pretty tricky in the first place, but also because there's not much room for error, and also because of these stupid black motor wires here. So the first thing I discovered was that you shouldn't put your heat shrink on until you've tinned up the wires, especially this one. I'm putting the heat shrink on the silicone wire, but when you're tinning it up, it heats up pretty quick, and if you have very small heat shrink like I have here, the heat can travel up the wire and start shrinking the heat shrink prematurely, so you don't want that. The other thing was, when you're if you use the tweezers to grab hold of this while you're heating it, because of the coating on this wire is so crappy, the tweezers can just squeeze through it when the heat comes along, and you might find you end up with a little bit of bare metal on here where the tweezers were squeezing. So that's no good. So if you want to squeeze while you're heating something, do it on the silicone wire side over here. So the way I've been doing it is tinning them both up, of course. You can't really tin up these single core wires very well. At least you won't be able to get much solder to stay on there. So don't worry about getting too much solder on that side, but put a little bit extra on the silicone wire side here. And one redeeming feature of these wires, the motor wires, is that you can sort of position them around a little bit because they're stiff, so you can get them to stay where you want fairly nicely. But I don't want to put too much heat in there, of course. Oops, sorry. So I just want to heat up the solder on both of them together and let them glob on like that. So not too much heat there. Well, once the heat shrink is on, that's my point. I think it may have even started shrinking a little bit there. Let's see if we can move that. It's a bit, it may have shrunk a little bit, damn it. Oh, I'm sure we'll be able to move it along a little bit later. Anyway, once you've done the soldering joint, you don't want to move this wire around too much, because I found that the problem I had with this was that even though the solder joint here is quite strong, it's right on the edge of the solder joint here where the black wire joins on, that if it bends one way and the other a lot, it'll just break there. So once you've done that, you want to kind of keep that part of it as still as you can. So what I'm going to do is tape them down so that they're all flat like that against the wood, so they can't move around. So that's the plan. But as you can see, I'm going on and on about this because it is quite a nuisance to have those crappy wires like that. And like I say, I found my previous quadcopter to fall out of the sky suddenly about 5 times, and I had to come home and solder it up and go back out again. So it was really annoying. And if you are not a total cheap ass, you may want to think about spending a few more dollars and getting a motor that's a bit better. I have one here that I haven't actually tried yet, but I've heard very good things about it. This is a Sunny Sky 2204 2300 kV motor, and it's a bit more powerful. It costs twice as much, but it's still only $15. So to get 4 of these instead of 4 of those ones would only be another $28 to the total project cost. But look at this, we have nice silicone braided wires in there. So all of this fuss that I've just been going through, I wouldn't have had to worry about it so much with this motor. And of course it performs a lot better. Seems unanimously people were saying that this is a great motor to get. That's why I got it. Keep in mind though, it has a slightly different mounting system on the bottom, so you can't put the zip ties through it directly like we did with the other one. What you need to do with this is get a mounting plate like that that goes on there, and then you could put the zip ties over the arms of this mounting plate there. So you can still do the zip ties strapped around the wooden beam kind of method that we did before, and this will come with the motor, so you don't need to get that separately. So that's just something to consider if you have a few more dollars to spare. Alright, next thing to do is take the fat silicone wires that came with the power distribution board, and you're going to have to solder those up to the Dean's connector. I'm going to put this one on, and I'm also going to put the other one on that's a little bit smaller. So I have some of my batteries are using that one, and some of them are using this smaller one like that. So what I've been doing so far is putting this little cable on, which is actually supposed to be only used for charging the batteries, but seems to work okay so far. But what I want to do for this quadcopter is to do it properly, and I have another one of these coming in the mail, so I'm going to put this one on there, and I'm also going to put this one on so that whichever type of battery I use, I'll have a plug especially for it. Anyway, what you want to do with this is make sure that the red cable goes to the top of the T. So if you look at this as a letter T, top of the T is going to be red, bottom of the T is going to be at the bottom, so it's ground, and that's black. One thing that can help when you're trying to tin these up, if you have a wimpy little soldering iron like I have, it can take a bit of time to get the heat on there, but you can take advantage of the fact that if you have some solder on your soldering iron when you start, it gets a lot more surface area to contact, so it heats up quicker. And the other thing is that if this plastic framing part gets too hot, it gets a bit soft, and the alignment of the pins can sort of slip a little bit. So it can help to plug the other side into the female connector like that, just to keep it in the right position. Although of course it goes without saying that you don't want this one to be a battery, right? Because then you'll have two open connections here that you're rubbing your soldering iron around on, and you might make a short. So only do that if you have a spare female connector like this, or one that's not connected to anything like that. And another tip for those of you with wimpy soldering irons, like for example I have this one here, which is, it's great for doing tiny detailed stuff, but it's not very good for these big heavy heatsink kind of wires. So what you can do is, instead of trying to heat up the tin that's already on the wire when you get it, you can just cut that off. Just cut a little bit off so that there's fresh wire sticking out, and that'll let you splay it out flat a little bit like that, and putting your own new fresh solder on there will be a lot easier because it will flow in much nicer, and you can heat it up quicker because it's thinner. And it also gives you a little bit more surface area to heat things through quicker when you're trying to stick it onto there as well. So hopefully that will help. Okay, that's that done. It's not the best joint I've made, but do make sure that this is fairly strong, because you're going to spend a lot of time, or many times, pulling. Basically you're going to be pulling batteries off like that using these two solder joints, so it has to be a fairly physically strong joint as well. And be prepared to pour a lot of solder in, because it sort of soaks in and up the wire. As far as I can tell, it just seems to keep needing more and more solder. Anyway, so that's that done. And one thing that's nice about this joint is that you can put the heat shrink on afterwards from the other end, just like that. Isn't that convenient? Okay, once the heat shrink is on there like that and it's ready to go, we have to stick the other end onto the power distribution board here. And because all of these pluses are all connected together and all the minuses are connected together, it doesn't really matter where it goes particularly, as long as you connect the red to a plus. So we could stick it like that, coming out the side even if you wanted to. The board is kind of made to use these ones here, but that doesn't really matter. So you could stick it here and have those wires coming out way out there. I've found in the past that it doesn't really need to be quite that long, and it was actually kind of a nuisance to kind of have to wrap this wire or strap it down somewhere, because it sort of jiggles around like that, and I found it actually interfering with the gyroscope a little bit. So I kind of want to keep it as short as I can, and I thought I might have it just sort of poking out like that from because there's going to be another board on here, right? But I didn't want to cut it very short, so instead of having it connected on here and poking out this side, I'm going to connect it here but poke it out that side, so I'll still keep about that much of the wire intact, and then I can just squeeze this around like that to connect it. And when that's connected on, careful here, I'm connecting the battery, that's why I have this little bit of tape around one of these leads here, so I don't cause a short. But basically it's going to be like this, and there's just enough room for this battery to be connected up when it's around from its furthest position, which is going to be the outside, and there's enough room for me to get it on and off without too much difficulty. And when it's on, it's fairly sturdy because this bit's going to be sort of held down, and it's not vibrating. It's not going to vibrate in the wind or anything like that. So I'm going to cut this a little bit shorter and join that on again. So you have to do the whole thing again with splaying out the thick wire and filling solder into it for hours. Well, not hours. It takes a lot of solder. It feels like it takes a lot of solder when you have one of these tiny little solder sticks. Anyway, let's do that. Okay, now when I connect the battery, we should hear the little startup chimes that chime that the speed controllers make. That doesn't sound quite right. There's supposed to be one more tone after that. So I'm not really sure why it's not doing that, but considering that we don't have any flight controller connected, it could be that last tone is means that it's fully initialized, and it doesn't do that when there's no flight controller. So sorry, I don't know the details there, but it doesn't seem like we've broken anything because it does that every time. So it's the same thing every time, so I don't think anything's broken. Anyway, the next step is to set up the flight controller and spin the motors just so that we can make sure that they're going the right direction, because if they're not, we still need to change these wires here, right? But I discovered that you can just use an ordinary Arduino to do that, and since I don't have my flight controller board yet, as I said, it's still in the mail, I'm going to try doing that with an Arduino Uno that I have, and you could do this with the Arduino Pro Minis, one of those if you have one of those, but it's a lot easier to do with this because it's got nice headers to plug things into. So if you have the flight controller board, you don't need to bother with what I'm about to do now. Whoa, wait a minute. So a couple of weeks have passed and I have my flight controller board now, and it turns out that you can do pretty much exactly the same thing as what I'm about to do with the ordinary Arduino. You can do that with this board as well. So just keep watching, and when I get to the part where I'm connecting the Arduino up, I will insert another little description of how to connect this board. But otherwise, everything else is the same. You use the same Arduino sketch and everything. But if you do want to try checking your motors with an ordinary Arduino, you can follow this next step. Okay, I gave this a try, and it seems like what I was saying before about not being completely initialized was correct. So I think the ESCs are waiting for a zero throttle signal to give you that final tone to say that they're completely initialized. Anyway, so if you want to try checking which way the motors are going to spin with just an ordinary Arduino, you can use this little sketch here. It's very, very simple. All it does is set up one servo attached to one pin. I'm using pin 9, doesn't really matter. Oh, well, it should be one of the PWM pins. And then we set that to 0, which is going to be 0 throttle, and then we wait for 3 seconds, and that gives the ESC, it lets it know that you're ready and everything's okay. And then we're going to set it to 70, and this value here is between 0 and 180, so 180 would be full throttle. You don't want to do that just yet. So start very low, like about 10, 20 or somewhere like that, and gradually increase it until the motor spins. And I've found that these motors and these ESCs, this combination together, usually starts to spin at about 70. As far as the setup goes, we only need 2 breadboard jumper wires. And the first thing we want to do is connect the ground on the Arduino to the ground on the battery so that they're working from the same ground level. And we can conveniently do that by using the black port, what do you call it, pin, I guess, on the balancing plug. So that'll be earth, black to black. And from pin 9, or whatever pin you chose to be the pin for the servo in your sketch, we'll put that to one of the control lines for one of our ESCs. So I'm going to put that to this motor here, which should be that motor, and have something on your motor so you can see which way they're spinning a little bit easier. Just makes it easier to tell. And I'm keeping track over here which ones need to be reversed. So this is motor 1. Now when I put this on here, it doesn't seem to do anything unless it gets that first 3 seconds or so of 0 throttle at the beginning. So what I need to do is reset the Arduino . Oh, other thing you need to do is plug the battery in. How about that? Let's try that. So battery goes on. Now we didn't get that last tone again, but if I reset the Arduino, we get it. Right. And I can see that motor's spinning that way, and it's supposed to be spinning that way. So number 1, giving him an X because he needs to be reversed. Okay, so that's how you connect up the regular Arduino to do this. Now if you want to use the flight controller board, you can do pretty much exactly the same thing, because this is actually functioning almost the same as an Arduino Pro Mini. So when you set up the, when you choose the board type in the Arduino ID for this one, you should choose Arduino Pro Mini 5 volts ATmega 328. So that's the board type. And to connect it up, you'll of course need an FTDI adapter thingy like this. And you can see where these all plug in here on the along this row of pins here. So VCC and ground go to the same one on the adapter. RX and TX get crossed over, so TX from here goes to RX on here, and TX from here goes to RX on here. And then the last one here is the reset pin on the far end, and that one I found should be connected, if you're using this same adapter, should go to the DTR pin on the right hand side, like that. And I've just taped these together to make it a little bit easier to plug in and out when I use it regularly. So that's going to go in there like this, and you'll see when I start it up, right here, you'll see that the LED is flashing there once per second. I kind of forget what program this came with when I got it, but I've put a lot of different programs on there just to try things out. So what I have on here at the moment is the blink, just a normal blink sketch that switches the LED on and off once per second. So let me just upload the servo tester sketch to the board. Okay, now to connect this up, it's basically the same thing. We want to use pin 9, or I'm going to use pin 9, and I'm going to use a male to female connector there. So in pin 9 I'll put that on, and that should go on the signal pin. So if you can see on the right hand side here, we have negative, positive and signal. That sort of bumpy square wave symbol means signal, So you want the signal pin of D9, and that's going to go into the speed controller there like that. And the only other thing we need is ground, and you can see there's a few different connections we could use for ground on there if we can focus. So there's actually 3, I think, or 2. So I'm just going to use one of those for ground, and that's going to be on the black wire of the battery balancing port. So that is black going to ground like that. So you should have something like that. Yep. And then we connect up the battery and we should be good to go. Let's see if we can get this. Alright, so I'll connect up this motor and see, hopefully we get the same result as we have with the ordinary Arduino. Oh, of course I need to reset it. So there's no reset button on this board. That's probably the only difference between that and most other Arduinos. So to reset the flight controller board, I'm just going to open up the serial monitor on my computer, because that resets the board. Okay, so now we can see that we have the same thing working as we have before. So now I can move on to this one, and you'll notice that what? Oh, I don't know what that was, but maybe it's complaining that it's lost the signal, I don't know. So anyway, we'll move on to this one, and you'll notice that it doesn't do anything until it goes through that startup sequence properly. So I'll restart the Arduino again. Wait 3 seconds. That one's going the wrong way as well. I wonder if they're all going the wrong way. I guess that's kind of the right way, isn't it? So anyway, on to this one. So I have to switch those 3 motors to be, you just need to pick any 2 wires and switch them over. So that's a bit annoying. It was 50-50 chance that each one of them could be wrong, and 3 of them were wrong, so that kind of sucks. But that's a quick way that you can check. Even if you don't have your flight controller ready, you can just use an ordinary Arduino to check which way the motors are going to spin. Okay, so I will switch those cables over, and then we are done for mounting the motors. So thanks for watching, and see you next time.